So, in this video I'm going to demonstrate the Pythagoras theorem. Well, what does the Pythagoras theorem state? The Pythagoras theorem states that in a right triangle looks something like this. A right triangle is a triangle that has a 90-degree angle, or 90 degrees over here. It doesn't matter what the angles are here, as long as there is one 90-degree angle over here, it is a right triangle, and therefore the Pythagoras theorem applies. The Pythagoras theorem says that c squared is equal to a squared plus b squared, or in other words, the longest side, c, let's put it here, c squared is equal to a squared, so this is side a and this is b, let's say. It doesn't matter, this can be a and this can be b. The only one that matters is that the longest side is the one that is equal to, the longest side squared is equal to a squared plus b squared. So it doesn't matter if you change b and a, it is exactly the same. So what it says is that this side square is equal to this side square plus this side square. Now, we need to remember, what does it mean c squared? Let's go back to something, to the area of a square. And let's put another variable, let's say that this is x. If this is x, the definition of a square is a figure that has 90-degree angles. All of the four angles are 90-degree angles, and all the sides are the same. So that means that if this side is x, this side is x. And the area is base times height, x squared. So if we have here c squared, that means that if we draw a square over here, and I'll try to draw it in proportion, which is going to be a little bit hard to do. Let's count, it's 1, 2, 3, 4, 5. So we need to go, actually it's more like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have a square over there. So c squared is this, right? This is c and this is c. We have here c squared. A squared would be this square over here. So this is a squared, and then b squared would be this square over here. This would be b squared. Okay, so now let's analyze the Pythagoras theorem over here based on our new figure. C squared is equal to a squared plus b squared. That means that this square over here, the area of this square over here plus the area of this square over here, must be equal of the area of this square over here. Okay, so now how can we demonstrate that? Let's draw a square here. All around our new c squared. So we're drawing a square over there. So you see that square? Let me draw it in blue, the new square. So you have this huge square over here. And what we want to demonstrate is that this plus this, the area of this plus the area of this is equal to the area of this. That's what we want to do. Okay, so let's analyze this new square. We have this triangle over here, and I want you to see this triangle is here, but it's like down. You see, this triangle is here. There is a way with geometry to demonstrate that this triangle and this triangle are the same triangle. We know that since we have a square here, this is a 90-degree angle and this is a 90-degree angle. So what do we have here? This side, and we have this angle, this side and this side, side angle side, side, angle, side. Okay? Actually, you can easily see with this figure, this is A, right? So this is going to be B. AB. Now, this is B, this is going to be A. There is a way to demonstrate with geometry, with side, angle, side theorems, that this is like that this triangle is equal to this triangle is equal to this triangle, and this triangle is equal to this triangle. So you have 4 triangles here. So if this is B, this is A, this is going to be B, this is going to be A, this one that I put X is not X, it's B. Okay, so we have A, B, A, B, A, B, A, B. Perfect. Now, we are almost done with this. Let's consider the area of all this square, the area of the big square. So it's going to be this side times this side. But what is the size of this side? Is BA, B plus A, right? B plus A is equal to this side. Let's put it here. I'm actually going to put it here. B plus A. Okay, so that's this side. And what is this side? Same thing, right? B plus A. So if we multiply that, it doesn't matter what it is. We will solve it. But if we expand that, we'll get the area of this square over here. And that must be equal. Now let's take all the small parts from the square. We have this triangle. I'm going to draw it in black. This triangle over here, plus this triangle over here, plus this triangle over here, plus this triangle over here, plus, and now I'm going to do the other, the lines in this direction, this square over here. Okay, so let's add that. We have 1, 2, 3, 4 triangles. 4 triangles. And the area of those triangles is base times height divided by 2. The base is A. The height is B divided by 2. So we have 4 of those. Plus, so far we have the diagonal lines, right? These diagonal lines, the area of those diagonal lines over there. What do we need to add? We need to add the area of this triangle, where the diagonal sides are in the opposite direction. So the area for this is very easy, right? Because it was C and this is C. So C and C, this is going to be C times C, C squared. We actually put it there, plus C squared. Okay, now I want to focus on this formula that we have here. Let's expand this. B plus A times B plus A is going to be B squared plus 2 times AB plus A squared. And that must be equal, what is 4 divided by 2 is 2. 2 times AB plus C squared. Let's subtract 2AB from both sides. So this cancels out, right? So you get B squared plus A squared equal to C squared. And that's the proof of the Pythagoras theorem. You see, we get exactly the same. So thank you. I hope this was helpful.